All right, now we're going to work on some solving equations. The key to these really is that your equal sign is a game changer. Your equal sign lets you get rid of the denominators in your first step. So we could multiply by all the denominators we have, x squared minus 9, x minus 3, and 1. But that's going to overcomplicate our situation. So factoring anything that's factorable to see if you have any terms in your denominator in common is really helpful. So now once you factor that difference of squares, you see that you have the x minus 3's in common. So what we're going to multiply everything by, every term by, is this x plus 3 times x minus 3. Again, we can do that because of this equal sign. That lets us just do what we do to one side of the equation to the other. So we're going to multiply every term. To cancel the denominator. If you like finding a common denominator, you can do that instead, and you could just cross multiply at the end once you have one fraction on each side of your equal sign. That's also a fine way to deal with this. But what we're going to do here is multiply every term by x plus 3 times x minus 3. So I'm going to give myself a little more room here. I like to write everything as a fraction. So I'm going to multiply by x plus 3, x minus 3. Again, we're not using fancy form of 1 here because we're canceling our denominators. We don't need fancy form of 1 because of our equal sign. Okay, now we can cancel some stuff. In our first fraction, everything cancels but the 6. In our second fraction, our x minus 3's cancel. So I have negative 1 times x plus 3. And on the other side of the equation, we really just have 1 over 1 times our difference of squares there. So we know that x plus 3 times x minus 3 gives us x squared minus 9. All right, that negative 1 is important. We do need to distribute that. Those parentheses are not optional here. And we need to combine like terms before we move across the equal sign. So 6 minus 3 is 3. And now we're just solving for x. Since we have that x squared, we need everything on the same side so that we can factor to solve. My x is going to be my middle term there. And negative 9 minus 3 is negative 12. I can factor to solve. Plus 4 minus 3. So my possible solutions are negative 4 and positive 3. Now the only thing we need to be sure of is that neither of these solutions would make a 0 in the denominator for our original problem. So we need to go back up to the top, and you can do this at the beginning of the problem or at the end. We need to go back up to the top and evaluate whether either of these would be an excluded value. When we look at these, our excluded values you can think of them as your places where you would have vertical asymptotes. That's where we have no values of y for a value of x. And here our excluded values would be x cannot equal negative 3 and x cannot equal positive 3. And so that does overlap with one of the answers that we got out. So positive 3 is not an actual solution, but negative 4 is. Again, you can do the excluded value at the beginning of the problem or at the end. Either one is fine. All right, so let's do another. I'll do B and the next problem for you as well on this video. They're all similar. B is actually a little easier. You have 6 times W is your most complicated denominator. So we're going to multiply, and that if we multiply everything by 6W, that will get rid of all of the denominators. Again, we can do that because we have that equal sign. Whatever we do to one side of the equation, we are doing to the other. That is legal. So So our 6w's cancel in our first term, so we're just left with 5. Our w's cancel in the second, so I'm left with 1 times 6, which is 6. And on the other side of the equation, I have negative 4 times 6w is negative 24w. So 11 equals negative 24w. Divide both sides by negative 24. You always want to keep an eye out for excluded values, especially on a multiple choice test, since on a multiple choice test, you're not going to get partial credit if you pick the wrong answer. You could just be forgetting the excluded value, so it's something to keep in mind. Here, we set all of our denominators equal to 0. Our excluded value is w cannot equal 0. So negative 11/24 is a solution that will work for us. That was a lot simpler than A. All right, one more. 1 minus 16 over x squared equals 6 over x. Again, we have x squared and x. Our most complicated denominator there is x squared. And if we multiply everything by x squared, we're going to get rid of all our denominators. So that's nice. So our plan was to multiply everything by x squared. Again, this is legal. We don't have to use fancy form of 1 since we have this equal sign in our problem. All right, nothing cancels in our first term. So I just have an x squared there. My x squareds cancel in my second term, so minus 16. And over here, it's really tempting just to cancel your x's, but only one x cancels. So I have 6x on the other side of the equation. Since I see that squared in the singlet, I know I need to bring my 6x over so I can factor to solve. We need to just remind ourselves to go back and do the excluded values, make sure none of our solutions come up as one of those. Multiply to negative 16, add to negative 6. It's going to be negative 8 and positive 2. Which means our solutions that we need to evaluate are x equals 8 and x equals negative 2. When I look back at my original equation, all I have are x's in the denominator, which means here our excluded value is x cannot equal 0. That's where your asymptote would be for this one. So negative 2 and positive 8 is a perfect solution. All right, those are the examples 4 and 5. You can look at the next video for complex fractions.